everyone. My name is Harnit Saini, Assistant Professor Ajay Kumar Garg, Engineering College. Today the topic of our discussion is theory of logic. Now let's start with it. First, what is logic? Logic is crucial for mathematical reasoning, important for program design. Used for designing electronic circuitry. Propositional logic is a system based on propositions. We will be talking about the propositions now. A proposition is a statement that is either true or false, right? The statements with which we can take the decision whether it is true or false are called propositions. We say that the truth value of the proposition is either true or false. Corresponds to 1 and 0 in digital circuits. If it is true, then it corresponds to 1, and if it is false, then it corresponds to 0. Now, let Px denotes the statement x less than equal to 4. What is the truth value of P0, P2, P and P6, right? Now, these are the propositions. The proposition is x is less than equal to 4. Now, we have to check the propositions with given numbers is true or false, right? Now, proposition is Px, x less than equal to 4. P0 is 1 less than equal to 4, which is true, okay. P2 is 2 less than equal to 4 is because 2 is less than equal to 4, we all know it is true. So, the truth value is true. Now, P6, 6 is less than equal to 4 is not correct, it is false. So, the truth value is false here. The statement or the proposition is 520 is less than 111. Is this a statement? Yes. Is this a proposition? Yes, because we are able to say whether it is true or false, right? What is the truth value of this proposition? It's false because 520 is not less than or it is greater than 111. Now, next statement, 2 plus 4 is equal to 6. Is this a statement? Yes. Is this a proposition? Yes, because we can have one truth value for this. Yes. And what is the truth value of this proposition is true. 5, 6 is a subset of 5, 6, 7. Is this a statement? Yes. Is this a proposition? Yes. And what is the truth value? True. Y is greater than 5. Is this a statement? Yes. Is this a proposition? Yes. Now, it is not the proposition because the truth value depends on the value of the y, but this value is not specified here, right? We call this type of statement a propositional function or an open sentence. Now, it is a statement, but it is not a proposition because the truth value is not, we are not able to make the truth value, whether it is true or false, because we don't know the value of y. Now, if the y is less than 5, then it is false, and if it is greater than 5, then it is true. So, at this moment, we are not able to specify that. So, the truth value is dependent on the value of the y, right? So, we can say that it is an open sentence or it is a propositional function. It is not a proposition yet. Today is January 27 and 99 is less than 5. Now, in this statement, we have to check two conditions. Like today is January 27th and means both the statements of the left hand side of the and right hand side of the and should be true when there is an and in between. January 27 and 99 is less than 5. If one of them is false, then the whole statement is false. Is this a statement? Yes. Is this a proposition? Yes, because we are able to make out whether the statement is true or false. What is the truth value of the proposition? It's false because one of the statement 99 is less than 5 is always false. Please do not fall asleep. Now, please look at this sentence. Please do not fall asleep. Is this a statement? No, because nothing is specified. We are just giving a command to someone, right? It's a request. Is this a proposition? No, because it doesn't have any truth value. Only statements can be propositions. When we are giving some statements, then only we can declare whether it is a proposition or not. Okay, but if it is not a statement, there is no question of being a proposition. Please report at 11 a.m. sharp. Is this a statement? No, it's an order, right? Is this a proposition? No. Only statements can be propositions. Now let's take another example. What a hot day. Is this a statement? Yes. It's a feeling of expression. Is this a proposition? No. Only declarative statements can be propositions. Okay, feelings are not the propositions here. Do you speak Hindi? Now, there's a question mark there. This is a question. No. It's a question. Is this a preposition? No. Only statements can be proposition. Now, do you speak Hindi? We cannot give yes or no answer. This is depends on the person whom the question is asked. So, it is a question, so we cannot take it as preposition first. Now, if the room is made of cheese, then I will be rich, right? This is some type of thought, like, is this a statement? Yes. Is this a proposition? Yes. What is the truth value of the proposition? Probably true. It may be depending, like, if the things are true. If the moon is made of cheese, then I will be rich. If the moon is sometimes made of cheese, then he can be rich, right? So this can be true. X is less than y if and only if y is greater than x, right? Is this a statement? Yes. Is this a proposition? Yes. Because its truth value does not depend on specific values of x and y, right? If statements, if and then statements, if and only statements are always propositions. What is the truth value? True. As we have seen in the previous examples, one or more propositions can be combined to form a single compound propositions, like we have studied with if statements, with if and then, if and only if. These all statements are compound statements. We formalize this by denoting prepositions with letters such as P, Q, R, S and introducing several logic operators or logical connectives. We will examine the following logical operators. Now, negation is, you can see, this is a symbol of not or negation, right? Conjunction, and, which we say and it is symbolized with the open triangle. And disjunction is or, and it is symbolized with the reverse triangle, open triangle. Exclusive or with the symbol plus, and then you have to make a circle on that. Implication, implies means arrow. Which statement implies the other statement? The arrow is in that direction. Biconditional, if and only if both the conditions have to be dependent on each other. Truth tables can be used to show how these operators can combine propositions to compound propositions. Unary symbol, unary operator symbol is negation. Only one statement is there, only one input is there. Like, if true, then it is false, and if it is false, then the negation is true. What is the negation of the following proposition? Today is Tuesday, right? What do you think will be the negation of this? Today is not Tuesday. No one wants to buy my house. You have to negate the statement. Someone wants to buy my house. At least, or you can write at least one person is there who wants to buy my house. What is the negation of the following proposition? 5 plus 1 is equal to 6. Is 5 plus 1 is not equal to 6. Some people have no bike. Every person has a bike. A cow is an animal. A cow is not an animal. Every even integer greater than 4 is sum of two prime numbers. Every even integer greater than 4 is not the sum of two prime numbers. This way you can negate the statements. Now, conjunction. Now it is a binary operator. We need two operands for this, P and Q. If for AND statement, where there is both are true, then only it is true. Like first statements like T and T, T true and true is always true. True and false. If one of them is false, then false. If one of them is false, this is false, so it is false. Both are false, then it is always false. Now, Ram is healthy and he has blue eyes. Now, we are having two statements, P and Q. For P, it is Ram is healthy and Q is he has blue eyes, right? Then P and Q will be Ram is healthy and he has blue eyes. This way we have to write, right? 5x plus 6 is equal to 26 and Q is x is greater than 3, right? Now we have to put an and in between them, right? The statement will become 5x plus 6 is equal to 26 and x is greater than 3. Now the disjunction operator, in which at least one statement has to be true, right? See here, P is also true, Q is also true, then OR is true. In second row, this one is true, this one is false. So at least one of them is true, then it becomes true. Here also, this one is true, so it is true. Both are false, then it has to be false, right? Now, the statement C, he will go to Delhi. P is he will go to Delhi and Q is he will go to Agra, right? Now we have to put an OR in this. So, what will be the statement? He will go to Delhi or Agra, right? Now, these statements which we are creating is true or false depends on the condition where it is implied. Now, here we are only making the propositions. We are not checking their truth values, right? Now, the next statement is candidate must know English and Q is candidate must know Hindi, right? So, then P or Q is candidate must know English or Hindi. Now, exclusive OR. Exclusive OR says both should have the same value, then it is the output will be true. Now, you can see here, true and true is always false. True and false is true, false and true is true, and false and false is always false, right? Means that when both the values are same, then it is always false. Implication binary operator symbol is arrow, right? Now we have to put an arrow from P and Q. This means if P then Q, right? Now check the truth table here. Both the statements are same, true and true, then it is true. P is true, it can be false, then this is false. Now here, if P is false, then Q can be anything, so it is true. P is false, Q can be anything, it can be true. Now here this statement you see, if P is true, then Q has to be true, but here it is written false, so this output is false, right? If P is true, then Q has to be true. If P is false, then Q can be anything, right? So in these statements we can put true. But if P is true and Q is false, then the statement or output will be false. I will get money, I will purchase computer, right? P implies Q. If I will get money, then I will purchase computer. Tomorrow is Sunday and today is Saturday. P implies Q. If tomorrow is Sunday, then today is Saturday. It rains, I will carry umbrella. If it rains, then I will carry an umbrella. Now, biconditional means both statements are dependent on each other. Now, here in biconditionals, both are to have the same values, then only the output will be true in the biconditional, right? Now, both are true, output is true. Both are false, output is true. Now, here it is both are not same, then the output is false here.